K-means and vector database have a core connection. There is a fundamental similarity between the two systems, and it's important to take maybe the knowledge you have from K-means and then also think about how you can apply that to vector databases. So let's first think about what's similar. In terms of the similarity, we have a mathematical foundation where both will measure the distance between points in space. We have k-means groups that are based on the closeness, and then the vector database is going to find points closest to the query. In both cases, they're going to convert real things into number coordinates. So the idea here is that with anything to do with machine learning, statistics, you need to convert it from some format into a numerical format. And then often you want to figure out a multidimensional relationship and figure out how close things are in multidimensional space. Obviously, XY is an easy multidimension space, but XYZ is probably even a little more intuitive in that in a three-dimensional plot, where are the coordinates that are close to each other? In the case of a k-means clustering, it would be clusters. In the case of vector databases, it would be similar items, right, or similar relationships. And then if we think about maybe treating k-means like a team captain, right, where the team captain is going to pick the certain people on their team. Similarly with the k-means, right, these are the centroids, but with a vector database, we're going to have similar representation points to organize the search space. So, hey, these are people that are really similar to me in social media. Let's see who they're following, and maybe I will want to follow some similar people, or I want to buy things that are similar to what this other person bought. In both cases, you're going to minimize this expensive distance calculation. So it's that distance in multidimensional space. So how do they work? The key intuition here is that there is spatial thinking, right? So you want to turn this object into a coordinate. In the case of height, weight, and age, I think this is one of the better ones to use as an intuition. We have the X, we have the Y, and the Z, right? Height, weight, and age. And then in a closer point, right, you have more similarities, right? If there's a retired person's softball league, right, they're going to have different height, weight, and age. If it's going to be a high school basketball team, that's going to have a very different relationship. But you can spot that, right, if you plot that into a three-dimensional space. And in both cases, you're going to handle potentially more than 3 dimensions. So you could handle 10 or 100 or 1,000. Now, there is one issue that does come up in terms of spatial thinking, and that if you have essentially infinite dimensions, then and you have too many features that you're comparing, then what happens is that everything is next to everything. So in the case of clustering, this starts to become much more difficult because of the fact that if everything is related to everything else, how can you make any assumptions about what's different or what's the same? But at the core, the distance measurement is this operation where you're calculating how far points are from each other. You can use different kinds of distance. You can do a straight line, you can do cosine, and then the speed is where you figure out how to organize these points or randomly start or what, there's some levels of sophistication in terms of the algorithmic component of the organization. And then the main differences between k-means and vector is that k-means is going to put things into groups. So again, think of the team captains in sports, and vector is more like, hey, who's like me? Like if you're a center that's 7 foot tall, maybe you say, hey, I need to guard the other center that's 7 feet tall, right? So you can think of just slightly different intuitions behind this. And then in terms of the query behaviors, the k-mean will iterate until there's stable groups, but a vector database uses pre-organized data, right? Because everything's already calculated, you already know in multidimensional space the similarity between every other thing that's inside of the vector database. So in the real world, how does this work? Well, similar products would appear on shopping sites, recommended songs on music apps, people you may know on social media. And the reason why they're so powerful is that it takes things that are really hard to compare, like movies and songs and products, and it converts them into a mathematical form that makes it much easier to compare. So again, if you follow somebody that has really similar taste in music, they like French movies, for example, and they haven't watched one of the movies that you've watched, and then maybe they would be very happy to receive that recommendation. So that's essentially the core intuition, but it again goes into multidimensional space. And it also can find patterns that humans might miss. And that's where the unsupervised machine learning, or in the case of vector databases, the similarity search really come into play. It's like, oh, wow, I can find all these hidden patterns. But often, again, the domain expert has to be involved to validate. Like in the case of a cluster, is this cluster even something we care about? But to wrap things up here, vector databases often use k-means internally. So many use k-means to organize their search space. There's similar optimization strategies, and both are organizing multidimensional space efficiently. But in both cases, you need, at the final level, human expertise, because the humans are finding the patterns, but they have no concept of understanding the meaning, and the experts are needed to interpret the results in the design space. And this is where the domain knowledge helps you understand why things are grouped together. So I think this is very interesting when you get into this, is that if you think about what k-means clustering really does, and if you've written the code for yourself, which I've written from scratch, k-means clustering, I've done lots of things with k-means clustering, I've plotted k-means clustering, is it gives you this really intuition around the large language models, because there's a lot of the same things happening, right? In that the large language models are finding patterns that are hidden, but just because you found a pattern, it doesn't mean that the pattern makes sense, or that the patterns, the way they're going to be used, make sense. And this is why, in a sense, at the best possible way to use things involving generative AI would be to have an expert human who is using it very similar to how an expert human would help classify k-means clustering. So I think this is a very powerful intuition that could help maybe demystify some of the problems that people are experiencing with thinking that, large language models are magic. But if you think about it from a mathematical component about the multidimensional space, and you're finding hidden patterns, and that the domain expert has to actually help determine whether that's a useful pattern, I think it actually is a very calming way to think about how good large language models are. It doesn't mean they're not very useful, because again, they can find these hidden patterns, but the real intuition here is that at the best use case of these new technologies, it's when the human who's a domain expert combines with the mathematical properties of these tools like k-means clustering, vector databases, and large language models.